to another class. We are going to continue with the application of logarithm. In this class, we're going to be looking at how do you apply logarithm when we have the roots. Before then, I want us to look at how do we divide logs, because it's going to be very keen in our study today. So, division of logs. An example there, you can be told to divide the following logs. Divide the following logs with part 1, 2, then part 2 with 3. For example, A, we divide 1.8624. So for part 1, we are dividing by 2. So 1.8624 divided by 2. This is just direct one. There's no issue. Divide by 2. 1.8624 by 2. You get to get, this is of course 1 divided by 2, get 18. So 0.9312. So that's how you divide by 2. There's no issue there. Then part 2, we divide by 3. The same 1.8624 divided by 3. We are going to have it as same case. When it is when the number is positive, when we have a positive whatever, it's going to be you divide it directly. So you get 0.6208. Part B, by 2.9754. So we are going to divide this number, this log, by 2 and 3. So the first case there, we have about 2.9754 dividing by 2. So when the number is a bar number here, and the characteristics is a bar number, the first thing that we need to ask ourselves is that number divisible by whatever we are dividing with. So in our case, bar 2 is divisible by 2 because 2 can be divided by 2. So in this case, we divide directly. We don't have any issue. Bar 2 divided by 2, we get by 1 point. And 0.9754 divided by 2, we are going to have 4877. 4877. For part 2, then by 2.9754 dividing by 3, we know that bar 2, when it's a bar number, we have to check first whether that number is divisible by whatever we are dividing with. In our case, minus 2 cannot divide 3. So when the number is not directly divisible, we first separate the characteristics and multiplier. We have it like this: bar 2 plus 0.9754 divided by 3. Then we make this bar 2 be divisible by 3. So what do? We add minus 1. So that you don't change the equation, we now add plus 1 on the other side. So that you can have bar 2 plus minus 1, you get bar 3 plus. This is 1 plus this is 1.9754. At the end of the day, we have not changed the question because we have added minus 1 here, and then we have added plus 1 on the other side, so that we can be able to do our question. This one we are dividing by 3. Now we can be able to divide. So by 3 divided by 3, so 3 divided by 3 is 1, because the bar number we have by 1 plus 1.9754 divided by 3. We are going to get it as 0.6 5, 8, 4, 6 recurring, and of course, because our table there, or because we use 4 significant figures, so this can have it as 1 plus 0.6585, and then we add the 2, we get 1.6585. That's how we divide the logs using that format. So the most interesting part is when you have a bar number, but when the number is positive, it divides directly. Now let's look at now the roots. Let's take an example. We have square root of a. In indices, we said the roots you can write them as, like if the square root of a should be a power a half. If it is maybe cube root of maybe a, this is going to be written as a power a third. So these roots, when we are dealing with roots, of course you can change them in that order. If it is n root of maybe a, then this one will be a power 1 over n. Divided by that number. If it's like fifth root, it's going to be 1 over 5, and that is how we look at that. Now let's have a question. We see how do you apply logs to solving such scenario. So we have a question here. Square root of 3.685 times 48.59 out of 5. So we have a square root of that number. Now using logarithm is a very simple task. So we create a table, one side number, then the other side logs, and we solve it. So for the number side here we have first one is in standard form 3.685. This is just times 10 power 0. Then 14.59, this is going to be 4.859 times 10 power, this is going to be 1, positive 1. And then we have down there 5, so 0 times 0 there, standard form. So we need the log of 3.685, and that one is going to be, of course, this is going to be 0.5664. Then the log of 4.859 over 4.59, we get 68, that is 1.6865. Then the numerator, we are multiplying them. So on the wrong side we add. So you get 5 plus 4, 9, 6 plus 6, 12, 1. 8 plus 7, you get 15, 1. 6 plus 6, also get to get just 12, 1 there. 1 plus 1, 2. So that is the numerator. Then we get the log of 5. The log of 5 is this is 0.6990. 6.990. Now, this is division. So, whenever you're dividing, we subtract the powers. So, you get 9 minus 0, 9. 2 minus 9, you borrow 1 there. And then it's 4. 12 minus 9, get 3. This is 4, you borrow 1, get 14 minus 9. That's going to be 5. This is 1. We borrow 1 from 2, get 11 minus 6, 5. So then this is 1 minus 0, 1. So when we divide that, we get it as 1.5539. So we are through with the multiplication and division. Then you have this square root. For square root, just as we have said here, it's the same as times power a half. So this one we multiply by power a half, that is the square root. Or in other words, we divide by 2. So 1.5539 divided by 2. Since it's a positive number, we just divide directly. 1.5539 divided by 2, we're going to get 0.7, also 14, remainder 115, 7 again equals of 14, remainder 1, 13, 6 equals of 12, remainder 1, 19, 9 equals of 18, and the 1, then 5 there. And then, because our table is going to be 4 significant figures, we get 1, 2, 3, 4. So we add off to 4 significant figures. So we get 0. This is going to be 10, 7, 7, 7, 0. So when you add off that one, then we get the anti-log. We get the anti-log of that. And that's going to be 0.777, going to be times 10 power 0, 0.777, get 5.984. So 5.984, that is the solution when we evaluate this one using the logarithm. That is our first example. Let's have a second example here. So there you go. We have example 2. We evaluate that using the logarithm. So the first thing, we make ourselves a table. One side number, other one the logs, like that. So 4.283 is in standard form. Then we have 0.009478. Make it, write it in standard form. 1, 2, 3. So we get 9.478 times 10 power negative 3. 1, 2, 3. This is times 10 power 0. So the also be 0. This is going to be by 3 point. We get the log of 4.283, which is 0.6317. And then the log of 9.478. That one is 0.9767. 0.9767. And when you look at this one, it is square. So we are going to multiply this one by 2. When it is squared, the power we multiply by that number. So this is a bar number. So if it is bar, when you are multiplying, we first separate the 2. The characteristics of the mantissa. Then we multiply them, 0.9767, we multiply by 2, so you get this could be by 6 plus 0.9767 times 2, you get 1.19534. So we add the 2, you get by 5.9534. So that is at the by 3.9767 times 2, we get about 5.9534. Then the numerator we will multiply by 2, so we add the powers. So you get this, we add to that, so you can write them here. 0.6317, we add about 5.9534. We are adding these two. We get to get 7 plus 4, 11, 1. 3 plus 2, get 5. 3 plus 5, get 8. 6 plus 9, get 15, 1. 1 plus minus 5. So you get minus 4. We write it as bar 4. So we are going with the numerator. Now we are come to the denominator. We have log over 9.814. So when we read the log of this log of 9.814, that is the number in this case. So we're going to read this number value here twice. So the log of 9, we look at what is this value of log 9.84. So log 9.814 is 0.9919. That is the log of 9.814. Now this number, now we get the log of it. So this is going to be 9.919 times 10 power negative 1. Power negative 1 there, so we're going to get by 1 point. Log of 9.919, that one is going to be 9965. Then we subtract the 2 because the numerator and the denominator, we have division side there. So on the wrong side, we just separate, we subtract the 2. So we get now, we go 1 from 5, from 11 minus 5, we get 6. Then we have 4 there, we go 1. 14 minus 6, get 8. This is 7, we go 1, get 17 minus 9, we get 8 again. This is 4. Now 4 cannot divide, subtract 9. So we are going to borrow 1 from minus 4. Let's see, minus 4, we borrow 1. So this case is going to be remain with minus 5. When you get, we borrow 1 from minus 4, we're going to be having minus 5. Then you're going to be having our 14 there, minus 9, which is 5 point. Now, bar 5 or minus 5 minus 1. Minus 5 minus 1 is going to be minus 5. Minus 1 by minus is plus 1. So you get bar 4 like that. So, from that, we are going to, we are through with it. We are through with the multiplication and division. Now we are remaining in this cube root. So for the cube root, just as we have said here, for cube root is the same as a power a that number power a that. So this one you divide by, we multiply by a that, or in other words, you divide by 3. So we have got by 4.5886, we divide by 3. So this is going to be, you check, if it is a bar number, you check whether it is divisible by 3. In our case, it is not. So we are going to separate the characteristics and the multiplier. We have the 4 plus 0.5886, then divided by 3. So we make this number to be divisible by 6, by 3, sorry. So for this number, for it to be divisible by 3, we are going to add minus 2. And then on the other side, so that you don't change the question, we also add plus 2. So that minus 2 plus 2 is 0. So we are not changing the question. So we are going to be having 4 plus minus 2, we get minus 6 plus 2.5886, we divide by 3. Then we are going to have, this is going to be by, so 6 divided by 3, that is 2. By 2 plus, now 2.5886 divided by 3 going to be 0.8 because of 24, and 118 going to be 6 because of 18, then 8, 2 because of 6, and 2, 26. We are going to be having 8 because of 24. Then you can reach at that point. So then we add the 2, you're going to be having 2.8628. Then we get the antral of that number. We are doing the log sides, then you get to antral. So this is going to be times 10 power minus 2. We did the antral of 0.8628. So we get the antral of 0.862, 0.862. Having 0.862, 7.278. That is 7.278. Then I add 8 there. Addition 7, 8 is corresponding with 14. I add the far end. We have 12, 7, 8, 9, and 2, 7.29 times 10 power negative 2. So we go backward 2 steps. get 0.07292. That is our solution when we get the cube root of those values using the logarithm. So when using the logarithms, our works is a bit easy. Okay, so let's look at example 3. So this one, when it's like that, you're using the logarithm to solve it. 0.25 is the same as what? The same as a quarter. So this is our quarter, or in other words, fourth root of this number there. So let's write it as that, so that you can go to go. Cos 12.8 squared out of 0.8452 times 140 power a quarter. Power a quarter, this is the fourth root. So to solve this one using the logs, it's just a simple task. One side you have the log, then the other side you have the number there. So cos 12.8. Cos 12.8. We read the logs, the log of cos 12.8 directly from the table of a logarithm of cosine, and this is going to give you about 1.9891. This is squared, so you multiply this one by 2, and whenever you multiply by 2, a bar number, first separate the 2, so you have bar 1 plus 0.9891 times 2, so you get bar 2 plus 0.9891 times 2, you get as 1.9782. So this is going to be bar 1, and you add bar 2 plus 1, bar 1.9782. Then come to the denominator, you have 8.452 related in standard form times 10 power minus 1. This is going to be 1 point. Then 540, 5.4 times 10 power 2. So that is going to be 2 points. Then we did the log of 8.452, and that is going to give us 9.92. 9270, and then the log of 5.4, that is 0.7324. We add the 2 because we are multiplying the denominator, so we add the 2. We are going to get as 4, this is 9, this is 5, and then 9 plus 7, that is 16, 1 plus minus 1 is 0, plus 2 gets 2 points. Then you have the numerator and the denominator. We have division, so we subtract the 2. So you get by 1.9782. We subtract the denominator, 2.6594. So we subtract the 2. So you get to get 12 minus 4, 8. This is going to be 7. I go on from that. 17 minus 9, you get 8. Then this is 6 minus 5, 1. Then 9 minus 6, you are going to get is 3. Then minus 1, minus 2, you're going to get as minus 3. So we are doing the multiplication and addition to that, the inside there. We have power 0.25, which is the same as our quarter. And of course, this is the fourth root. So we multiply by a quarter there. So let me have another side here. The number, then the log. So we got minus 3 or by 3 plus, we subtract the 2 because 3 is not divisible by 4. If it is a number, a bar number you have said is not divisible by 4, we separate the 2 plus 0.3188 divided by 4. Then we make this number to be divisible by 4. We are going to add minus 1, then you add plus 1 on the other side, so this can be minus 4. So we add minus 1 there, and then you add plus 1 on the other side so that you don't change the question. So you're going to have bar 4 plus 1.3188 divided by 4. And when you divide by that, bar 4 divided by 4, you're going to get bar 1 plus 1.3188 divided by 4, you're going to get as 0.3297, and then we add the 2 by 1.3297. So we are going to know on the rock side, you get that number, you go to get the answer, and this is going to be times 10 to the negative 1. So you get the answer of 0.3297. 0.3297 I have here is we first get 0.329, which is 2.133. Then I add 7, and that corresponds with 3 there. So I get 6. This is 3, 2.136 times 10 to the negative 1, which is same as now. We go back one step, 0.2136. So that's the solution to that question when you're solving it using the logarithms. So let's have our last example. So when we just write that, this power is minus a half. And if you can remember well, in our indices, when that power is minus, that one means the reciprocal. So you can see that one to work when it is positive, and then just reciprocate our value inside here. So you can divide it as the log of 4.8 out of 7.627 times 0.3734. This is now power positive a half. To change that power, we reciprocate the same. So let's have now the table here, number, and then the log, so that you can be able to solve that. So now 4.8, the number that corresponds to log 4.8, we did that log is 0.6812, 0.6812. Then we find the log of that, because now the log of 4.8 is our number here. So this is 6.812 times 10 to the negative 1. So it's going to be 6.812. We have 0.8332. Then you count the denominator part, 7.627, 627 there. Then the one is 3.734 times 10 power minus 1 times 10 power 0. That is 0.1 point. So the log of 7.627, I have 0.8824, and then the log of 3.734, the log is 0.5722. So we are multiplying the denominator here, so we add the powers. 4 plus 2, 6, 2 plus 2, 4, 8 plus 7, 15, 1, 8 plus 1, 9, plus 4, 14, then 1 plus minus 1 gets 0 point. So this is the denominator, and that was the numerator. We subtract the 2 because of the division sign between the 2 here. So we get by 1.8332, we subtract 0.4546. We subtract the 2 there, get 1, 2, 3, 12 minus 6, 6, then 2, 1, 12 minus 4, get 8, then go on again there, doing 7, 12 minus 5, 7, and then get 7 minus 4, 3, then minus 1, minus 2, that is 1. So we are through with the addition, multiplication there, and the next thing here is for us to now to multiply by this power half, which is of course the square root of this. So multiply by a half. And then when you're multiplying by a half, or when you're dividing by these two, we first, if it is a bar number, we check whether it is 1 by 2 directly, which is not. So we first separate the 2 by 1 plus 0.3786 divided by 2. So we make this one divisible by 2. So we are going to add minus 1, then we add plus 1 on the other side. So that by the end of the day, we don't change the question. So we have minus 1 plus minus 1, we get minus 2 plus 1.3786 divided by 2. And then this is going to be by 2, divided by 2 is going to be by 1 plus 1.3786 divided by 2, we get to get as 0.6893. Then we add the 2, we get by 1.6893. And when you're through with that work now, we can go back to the row and row to the number. So we do it at row. This is going to be 10 power negative 1. Then we did the row of 0.689. 0.689 I have as 4.887. Then we add 3, correspond with 3. Get this is 10, 1, 9, this is 8, 4.890 times 10 power negative 1. We go back one step, we get 0.4890. So that's how you can be able to solve that kind of a question using logarithm. So that's mark the end of our session. Thank you very much.